Hello and welcome to this video tutorial in which I'm going to walk you through our matrix measure template. But before we look at the template itself, I'm going to introduce you to the steps that we're going to look at during this video tutorial. So first I'm going to explain when and why you need a custom measure and thus a matrix measure template or something similar to that. We're looking at the template itself, and then we're going to look at the routing matrix input template that we have available as well, and connect those two templates. And last, I'm going to invite you to the following link that you can already see on my screen, which will introduce you to some more matrices or matrix providers that we offer. So that will be the last step. At first, I would like to give you an explanation on why and when you need a custom measure. A measure is, for us, something that a matrix that measures the costs when you go from one point to another. Usually, in the simplest form, that happens via _. But of course, that is not always suitable depending on your requirements, and you would like to use some different matrix, maybe from OSRM or from Google, or maybe some other provider that you might use. Why is this important to understand when you use the Nextmv infrastructure? That is because the Nextmv infrastructure runs all models in a self-contained environment, which means you don't have access to the outside world while the model is running. And that means that you have to provide all data that is needed by the model via an input file, and you cannot generate this data from within the model while it's running. So this is going to be solved with our measure matrix template. So I'm going to show you how you generate those matrices, and then how you can pass them into a serializable form so that you can consume it or put it in an input file that can be consumed by your model that you run in the Nextmv infrastructure. So at first, I'm going to show you my terminal, and please make sure at first that you have the latest version of Nextmv in case you already installed it. If not, if you haven't installed it yet, please go to our website, log in, and then you can follow the steps that you can find there. But if you haven't installed the latest version, you can do that by simply updating using our Nextmv CLI. Once that is done and you have the latest version, you can run the following command to create a matrix input example that we have that you provide via a template. So Nextmv init -t, and then it is measure matrix. And when you run this command, then it will automatically download the files and place them in the folder measure matrix for you. So I'm going to open the workspace file that is in this folder. When you look at this, you will see there are just a little bit more information about licenses, and there's a README also. But we're directly interested in the workspace file, so I'm going to open this with VS Code, just like that. And I'm going to make this a little bit bigger, and we're jumping into the main Go file. So at first, in this template, we're going to create an input struct that holds the most important, or the important data that you need to create a measure, or a matrix that holds all the information that you need to apply costs when going from one point to another. That is some stops that you want to calculate routes for, and maybe optional starts and ends. Those starts and ends are the start and end locations for the vehicles that you're using. And last but not least, the vehicles that you're going to use to calculate the routes. And we also have an output struct, which we have defined because this is the output or the output data that will be consumed by the next template that we're going to look after. If you remember, we have the routing matrix input template, and that will consume the input data exactly in this format. So, and then we're already in the main function that is going to be called when you run this template. To make it simple, I will just create a new input variable that holds just two stops, in this case stops in Berlin, with no vehicle starts, but with an end location for one of the two vehicles, vehicle 1 and vehicle 2. And this is to show you that you can have any combination of starts and ends according to your requirements. Now that we have some input data that we can work with, and we will create a slice of points with this route.buildMatrix request points function, where we just have some parameters that we have to that are used as an input. Those are exactly the inputs from our input struct. So we have the stops, the starts, ends, and the length or the number of vehicles that we have. So in this case, it will be 2 vehicles. And this slice, that is what we're going to use to create the distance matrices and the duration matrices for, in this case, with our OSRM client. So what you need to do here when using this this example is you need your own OSRM server that holds a map that has the points for Berlin or for your own points wherever you're trying to create your routes for. And we have a snap radius so that if there's no point on the road grid nearby, then the question is how far can this go and make a snap to this, where 0 means unlimited. And the next thing is we're using the client we created here to create a distance matrix and a duration matrix. We do this by using our OSRM package. We are asking for a distance and durations matrix via this function. We pass in the client we created, the points we created, and another parameter for the number of parallel queries. That is something that you should set according to your server capabilities. The default value is 0, and it will split the request points according to a default value. Now that we have a distance matrix and a duration matrix, we need to do an override of some of the costs that may have been returned by the OSRM server, and we do that using the override 0 points function. Again, we pass in the points and we pass in the distance matrix or the duration matrix respectively to override costs that the OSRM server return for empty points, such as the end location for the second vehicle or the start and the start locations for both of the vehicles. That means the OSRM server will return a very high cost for those points that it cannot create a route for, because those points are not available. But in our case, what we actually mean is that we don't have those points available, so we don't want them to go to a specific start, to start from a specific start or end at a specific end location. And that is why we will set those values to 0. And we do this by using the override 0 points function. And that is basically everything. Now we only need to create an output format that can be used by our next template. And that is why we create a new struct and pass in all this data that we see here. So we have the stops, the starts, the ends. Note that we also make a small conversion from measure.point to route.stop, because that is what the other template expects. Then we convert also measure.point to route.position. That is also for the same reason. We can just reuse the vehicles we defined in the beginning in our input struct. And last, we will create shifts that we will use to have an ETA output in the routing template, which comes next. And we have the distance and durations matrix that we're going to pass in as a float by float matrix. So since this is one of the more important parts, or the main purpose why we're doing this conversion, or why we're using this template, I'm going to look at this function as well. You can see it's a really small one. We're just going over the complete matrix that we pass in. So this is either the distance matrix or the duration matrix, and we go every point in this matrix to create and return a slice of float. And then the last step is, in this example, we're creating a file that we call routing-input.json. There are other options. You can also write this to stdout, or maybe you want to read in some additional data as an input. Maybe you don't have the points already in here, like in this, like the template suggests, for to keep this template simple and to better explain the main point about generating matrices and make them serializable. You can create your own input reader of different types, whatever you see fit for your requirements. When we run this, this will run for a short moment. And of course I have to put in a valid ID for the OSRM server. So I'm going to pause this for a quick second. Before running this, we of course have to give this a valid OSRM server. I'm going to use the free-to-use OSRM server, but please don't use that in your production environment, because we don't know how reliable this will return your matrices. This is just good for testing. So when we run this, we will see that we get a routing input JSON created, and it contains a duration matrix and also the distance matrix that we were interested in. So going back to our introduction, you can see this is the part that we already completed. Now we're going to look at the routing matrix input template. To do this, we will create a new template, and we will do this by using by using the template command for that. So nextmv init-t routing matrix input, and when we run that, we have a new template created. I'm going to cd into this to show you what it is, what it looks like. We have, first of all, the same structure. As you can see, it's pretty much the same. The only difference here is that we have an input JSON as well, and we have an input JSON. The main.go, of course, will look differently, but structure-wise, it's the same. So let's open again the workspace file that is available, and let's look at the main.go. The main.go will run again the main function, and it will start a runner which starts this solver function, which we can find just here, and it will run that. And the solver function takes two input parameters. First, an option struct. Those are options that are being used by our solver. You can have them in your arguments when you run this binary, or you can also use them as inputs depending on your needs. We will skip this for now and have a closer look at the inputs, and you will see that this input struct is exactly the same as the output struct from the other template. So when we run this template, we will eventually come to run the solver function, and we will create a distance matrix and a duration matrix. Both of them start of type slice of route by index with a length of vehicles. And what we're going to do is we will loop over the vehicles that are available here, and from the distance matrix and the duration matrix that have, as you can see here, that are type slice of float, we will create measure by index measures using the route.matrix function. Now we have a slice of the required route by index matrices, and we can create a new routing model with this. We have the stops, the vehicles, and we also set the value function to the distance matrices, and we use the travel time measure to use the duration matrices. We also add in the shifts. Those don't need any conversion, and we can just use them. And depending on your model, we will also use the route starts and the route ends options. That depends on the template from before, if you have vehicle starts or vehicle ends that you're going to use. And last, we're just making sure that we have an expansion limit of 1 set, and if you're not providing any options from the outside, we will just make sure that we have a runtime of 10 seconds, and we will solve the model. The options that I was talking about, they are being set in the workspace file as arguments. So we have the runner input path, where we will by default set the input JSON, which is the file that comes with the template, and we have the runner output path, and we will create, or the solver will create, an output JSON right here. So the input file that we have is similar to the one that we created with the matrix measure template. So you can see here that we have also a duration matrix and a distance matrix. And when we run this, we can just debug this, and we will see that a new file was created, and this is the solution that our solver created for it. Now, what would be interesting is to see how that connects with our other example. And as I said, this example creates a file called routing-input.json. And when we go back to the routing matrix input template, we can also say that we want to use the file created by the other template. So we just need to set give that input file, which is which you can find here, to in the argument list. And when we run this right now, I will delete this as well to make sure that we're creating a new file and that you can see that it's a new file. We will run this, and this file does not exist because I believe there is some typo somewhere, because it's measure matrix, not matrix measure. Okay, and now we have a new file created, and we can use this, and we can see that there is a new solution from the template that we created prior to using the routing example. So it might be that you don't want to use an OSRM client, and that is fine. What you can do, what we can give you directly, is when you go to this link at docs.nextmv.io docs/tutorial/vehicle routing/routing matrix. Then you can go to the dissecting matrix app and scroll a bit down, and here you can find the code for creating an OSRM matrix, but also for creating a Google matrix here and Routingkit. And with this, you can upfront create your matrices and serialize them in your input file that then can be consumed by your routing app that is running in the Nextmv infrastructure. I hope you enjoyed this tutorial and that it was helpful. If not, you can always connect with our support at nextmv.io, and see you next time.